Alright, fourth graders, we have arrived to lesson 7 and we're going to begin by looking at what our goal is today and various ways to look at lines, rays, and line segments as they relate to angles. Okay? And our target today is to use the protractor as our tool to measure and determine these angles and look for applying the terms that we have previously learned for acute, straight, and obtuse angles. And also, you are learning about angles that will either be complementary to each other or supplementary to each other. So let's go ahead and start. All right, so here we have a figure 1 through 4, and these figures are for us to make some predictions. So we're going to look at figure 1 to begin with, and in figure 1 let's go ahead and make some predictions. So look carefully at how things are labeled here. To make them clearer, I'm going to create some points on our lines. Okay, so say we have points here for X, Y, and Z, and let's try to make a prediction. First of all, ask yourself, if you were going to measure these, how might you go ahead and put your protractor onto the page to find out the actual degrees from the angle X, Y, Z. So let's go ahead and write that. Angle X, Y, Z equals to, and we'll have a question mark. What is that equal to? You can remember, you can use your tool again, and the best tool besides your brain is to take the protractor, place it on your page, and we're going to extend out these actual lines so we can see them much more easier using our protractor. Okay, so I'm going to go ahead and extend those lines. Then I'm going to take my protractor and look for a way to set the target, which is the hole in the center and the bottom, as you see, placing it on the point Y. Okay, so here's our point Y. I'm going to place my protractor. I can either start and flip the page upside down. I could measure from, in this case, left to right, starting on the left side. So I'm going to place my target down, and I'm going to go ahead and take a measurement, starting at 0 on the left and then counting. So I would go 10, and you're going to see me writing off the page a little bit. So let's zoom in for you a little bit closer. Here we go. Okay, so I got 10 starting on the left, and 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, and let's make sure we're lined up properly. Okay, and approximately I'm going to go round up to 135. Okay, so flipping my page back writes it up. We'll label that. And that angle measuring from here to here is 135 degrees. Okay, so now we can go ahead and say it's 135 degrees. Could we have made that prediction with just using our naked eye or not? Probably not. However, what I want you to look at is, can you make predictions, because we see that these two lines right here, this line and this line, these are both parallel, right? So we have line WZ, and that's going from here to here, crossing over the two parallel lines. So can you make a prediction on what you're looking at here in terms of other angles? What is this angle, do you think? If you're using your eye, you might say, hey, that angle looks a lot like the one above it. And you'd be right. This angle is also 135 degrees. Okay? What about this angle? If I look at the mirror angle, or say the opposite of the vertex on this side, what would be that angle? and you'd find out that one is also 135 degrees. So then this angle below it magically seems to be 135 degrees also. So there's some interesting things happening here. All the angles that you see that are opposite are equal when you have parallel lines with a single line. In this case, this one here that's passing. I'm going to change the color, so let's go ahead and choose that color, and you'll see that when this line passes through two parallel lines, then we have some continuity or equality between those angles that are formed. Okay, so I just want to make sure you see the observation and ask and wonder what's going on there. Okay, all right. Let's look at figure 2 and take a look at what we have there. Okay, again, can you make a prediction about this angle? What are some of your observations? Well, is it less than or greater than our reference angle, which is 90 degrees? And you can see it's definitely less than, so we know it's called an acute angle, right? It's an acute angle. Can you predict exactly what that angle is? Probably not without a protractor, so we could extend that angle out again by extending the line segments that they provide you. Now, you could say it looks like somewhere halfway between 90 degrees if you were to extend that and then create that 90 degree there, but we're not sure, so we could take the guess and say angle ABC could be approximately 45 degrees. And you notice I use this symbol here because that symbol represents about. So we're sort of estimating. This is about, or approximate is the right term. So we can go ahead and take that protractor again and turn. I'm going to turn my page sideways. And then I'm going to reference this as my 0 degree here. Okay, and then I'm going to measure from my right to my left this time. Okay, let's take a look there. So right to left, and I'm going to follow the arc. So I'm going to measure where it goes, where it ends up. So that's 10, 20, 30, 40, and guess what? It's 45 degrees, folks. So we got it. It's actually equal to 45 degrees. So now we know with certainty with the protractor that is equal to 45 degrees. So if this arc right here is 45 degrees, and now we can confirm that if we created another line, let's call that A and then B, right, from our vertex to that line segment, then this angle remaining is also 45 degrees. Okay, so name convention means you give your lines particular names at points so that you can call out or make a reference to it. Okay, so let's try something on figure 3. Figure 3, can you predict what this might be? Well, first of all, you can put your protractor and use your eyes and say, well, I can definitely tell by looking at the vertex that this is greater than 90 degrees. So I could draw that just to make proof to myself that that is definitely greater than 90 degrees. And I'm drawing a dotted line because there is no line there, so I'm just proving to myself that this arc formed in this angle DEF, angle DEF, is greater than 90 degrees. Okay, so therefore we know greater than 90 is therefore called obtuse. And what could it be? I'm going to take a guess. It's we know it's greater than 90. This angle formed, and I'm going to call it out. I'm going to go call this G because I just want to show you through proof that the angle we say FEG is equal to 90 degrees. And let's say if you estimate angle DEG, I'm going to say it looks like it's 30 degrees, just by the mere fact that I've looked at angles a lot, and it seems like it's less than 45. So somewhere, if it's a special angle, it could be 30. So let's take our protractor again to the page, place it down, and find out. Okay, here we go. We are going to use line segment or line EF or ray EF in this case because there's only one arrow from the vertex. I'm going to measure around all the way to ray ED. Okay, so here we go. It's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. And so if you take a look at this, if that's 120 degrees, 120 degrees starting at F and following the arc, then you're going to realize it is truly, these two are correct, because 90 plus 130 is going to give you angle DEF. Therefore, it is 120 degrees, and I was right. DEG is 30 degrees. Okay, so you can write it both ways, this name, but you can say angle DEF is equal to 120. Okay, and then let's look at this last one here in figure 4. Again, if you need to extend these line segments, or if it's array, you can do the same on the page. But we see now the arc, instead this time, is going around the outside instead of the inside of that angle. So angle, how do you call that out? The angle that is opposite of angle SRQ or QRS is what we're looking at. So how do we measure that? We can make a prediction right away and say we know it's greater than it's greater than 90 for sure, and it's greater than even a straight angle, which is 180. So it's clearly obtuse, this angle, right? If we're measuring from here to here, but it's not exactly convenient to use our 180 degree protractor to figure out what this angle is. So I'm going to show you a little method how to do it, and it's going to require us using some of our operation skills in either addition or subtraction. So instead, I'm going to first take a measurement of what this angle is here. So I want to find out first, step 1, what is angle QRS, right? Okay, so let's go ahead and take our paper, flip it upside down. We're going to use our 0 is going to start here, 0 degrees. And it's upside down. I realize as you're looking at this, but that's why I flipped it upside down. And then I'm going to measure out the angle. And I'm following all the way around here, 10, 20, 30, 40, 50, 60, 70, 80, 90, all the way to here. And I end up at 130 degrees. So that's 130 degrees. So now we have to ask ourselves, what's this angle that is going to provide the final degree turn? We say, well, we know it's 360 degrees is a full circle. So a full circle is equal to 360 degrees. If I were traveling from here and going all the way around, that's 360 degrees. So now I can do some logic or math and say, well, then if angle QRS is equal to 130 degrees, then step 2, and I can say, well, that's got to be 360 minus 130 to give me my remaining amount, which ends up being 230. So this angle now I can figure out is going to be this angle here is 230 degrees. Okay, and I didn't have to use my protractor to determine that because I found out that QRS is 130 degrees. Okay, looking at the next page here, we're on the construction of angles that measure given numbers of degrees. And in these problems, we're going to use the ray shown as one of the rays of the angle with its endpoint as the vertex of the angle. So there's a lot to swallow here. And so let's slow down and figure out what they're really asking us. Okay, so they want to use the ray provided, the angle that they gave us, and draw an endpoint such as this one here to begin our vertex, and then create an arc to make the angle that's given. Okay, so let's take a look at this. For number 1, we want to take our protractor, realize it says 30 degrees. So we're going to go ahead and use our protractor and place it on the page, putting our vertex point right there at that end of the ray here. Then we're going to create a 30-degree angle or arc. So really what we want to do is going from 0, we're going to say 0 starts here, and we'll follow it around, and it's 10, 20, 30. So now we can go ahead and take our protractor, the ruler portion, the straight edge, and then create another ray. And in this case, we're going to follow that out. And here we are, 30 degrees. Okay. Let's try that again with number 4. I'm going to just choose a few of them because it's your job to practice a number of them in the problem set and the homework. So I'll choose ones that I know are fitting for challenging our learning to see different types of angles. Okay, so it's 135 degrees. And I want to create, again, another ray from there. So your choice on how you want to go about doing this. I'm going to go ahead and try going from the left to the right this time. So that means I'm measuring in this direction. Okay, so now I'm going to go ahead and place my compass down, and I'm going to call it out. This is going to be obviously my vertex point with a target on my compass, and 0 degrees starting this way on the left side this time. Okay, so now let's go ahead, and if you need to extend the line or the ray, that would be helpful too. In this case, I'm going to place that and say, what's 135 degrees look like? Well, this is starting from 0. There's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, and 130. And it says, well, got to go 5 more clicks. So 1, 2, 3, 4, 5. And there it is right there. That's a 135. Place my straight edge down, which is the bottom of your protractor, and create a ray. There it is. So this is going to be 135 degrees. Okay. All right, some more to practice here again. This time I don't see anything on the paper. It's just a blank area with the angle, so it's my choice how I want to create 175 degrees. Well, ask yourself again. Don't just jump in and start doing the problem. Think and reflect on what you know. We know that acute angles are less than 90. We know that obtuse angles are greater than 90. We know that a straight angle is 180. Well, what number is 175 close to? Yeah, it would be a straight angle, and 180 degrees is just a horizontal or vertical line. So I'm going to go ahead and first create a horizontal line here, because I just want to see what does 175 degrees look like compared to a 180 degree straight line. So let's create an array. Okay, and I'm going to say that's my vertex. So now I'm going to go ahead and measure that, right? So I could place my compass. In this case, I can go ahead and put the vertex over here at that point, and then go ahead and figure out what does 175 look like. Well, I know this is right here from this point, let's say that's A and that's B. We know that's 180 degrees because that's a straight line. So 175 has got to look close to 180 degrees. So I take my protractor, I realize, oh, look at, if I count from 0 starting on this side and I keep going around, I'm going to end up where? At someplace in this direction. Right? So where will it end up? 0 starting at B point, going around, and then ending up at somewhere there. It is going to look like this, 175 degrees. Okay, so that's a little challenging, isn't it? Because it's just shy of a straight line, so that's 175. 27, is it acute, straight, or obtuse? It's an acute, because it's less than 90. So let's create an array. One ray. Let's create my vertex point, and then measure from right to left this time. Okay, so 10, 20, 25, 27. So let's go ahead and take our straight edge. Therefore, this angle, 27 degrees. All right, so I'll leave it to you to practice again using your protractor to figure out various types of degrees through the exercise in the homework as well. You can just use these as examples. Okay guys, I want to bring your attention to different types of protractors that you may come across in your math journey. This one you're looking at is called a 360 degree protractor. You'll note that your protractor in comparison to this looks like two of them glued together to make a full circle, because you're using a 180 degree protractor from CSI. So if we were to take our protractor and measure the angle, normally we'd start here and then we would go in a counterclockwise fashion. So 0, 10, 20, 30, 40, 45, 90, and then all the way to 180. But you can take a look on this protractor. What's happening here is you're getting two angles that are shown. And this angle that I'm kind of circling right here, it's telling you the equivalent angle if you were measuring the opposite. So if I started again back here at 0, then if I went the opposite way, so I went clockwise, continuing on, the smaller angle you see on the bottom down here is going to be counting forward, yet at the same time the bigger number on top is going backwards. So why is that? And that's because we know that if you're going clockwise or counterclockwise, then the protractor has two numbers, right? You have two numbers. It's in right here, it's 0 and 180 are opposite each other, and you'll see here it's 0, 0, right? Because you're looking at depending on which way you're starting. So 0 and 0, you're going clockwise 10, 20, 30. Or if you started here on the inside numbers or angles, then it's 350, 340, 330, and so on. So it depends on how you want to use your 360 protractor to measure things, but the nice part about having one is that you don't have to rotate the page or turn things upside down to figure it out, because all the angles are represented on the inside measurements for angles or the outside. So this is a nice tool so you can see the comparison between 10 and 350. And if you look here, well, what's its equivalent? You have 90 and 270 here. Again, 180 and 180 depending on both sides. So those two match up. 0, 0 again, and then it just repeats itself. So it's a mirror image of what is happening in terms of angles.